as you probably have noticed. Since I said they were straight lines, each of these is a straight line. Very good. Okay? So this line has an equation, right? Okay, so let's just call this line, let's call this function f of x. It's a linear function because it's a straight line, so it's m1x plus b1. Will you accept that?
I accept it.
Okay, well, that was nice of me. Okay, so this one I'm going to call g of x, and I'm going to call it m2x plus b2. Now, m1 and b1 and m2 and b2 are unrelated numbers, but they're just numbers. Whatever the slope of this line is, that's what m1 is, right? Whatever the y-intercept of this graph is, that's what b1 is. And whatever the x-intercept or the y-intercept of this graph is, that's b2. Whatever the slope of this graph is, that's m2, right? And then we have the blue graph, which I have to write big so everybody can read it. Okay, we have h of x equals, what do you think? m3x plus b3. Where m3 is the slope of this thing and b3 is whatever that y-intercept is, right? Now, next time you're going to get problems that say, okay, give you a graph. They say scale the graph any way you want to. That means you can put any number somewhere on the x-axis, but then the rest of the numbers in the x-axis have to be consistent with that. And you put any number you want anywhere on the y-axis. I would pick one of these x-intercepts, probably the one on the positive side, and put a number on that to make it easy, right? And I wouldn't use a number like 17.832 square root of pi. Okay? I'd use a whole number. Okay? And then I'd probably use a whole number here so I know what m1 and b2 are. Okay? But then I'd have to get my m1 and b1 and m3 and b3 from whatever scales those numbers dictate. Understand? Okay? Now, my question is, where is the function that I'll call k of x equal to f of x times g of x times h of x where's the value of that function 0?
Say what?
Sorry? Well, I wish to convince you that the only way this product can be 0 is if one of these is 0, right?
Yeah.
Okay, well, where is f of x 0? Here. Right? Where's g of x 0? Here. Where's h of x 0? Here. So the answer is wherever the graph of one of these functions, and you know which ones I mean, cross the x-axis, right? Okay? Now, let's just say, first of all, what kind of function do you get if you multiply these?
You have,
Well, you're going to write this expression times this expression times this expression and apply the distributive law, right?
oh, so you get a.
And you're going to get something times x cubed because you're going to have an x from this one, an x from this one, an x from this one, right?
Yeah.
And then something times x squared and something times x and then just some number. Okay? We'll work out details of that next time. But it's going to give you a polynomial of degree 3. Some multiple of x cubed plus some multiple of x squared plus some multiple of x plus some number. And you can see that if I multiply something like this times something like this times something like this, that is what we're going to get. But we'll work through the details of it. Okay? So this is a polynomial function that's 0 at this point, and this point. Okay? Then there's the question of where is it positive and where is it negative. Okay? So we need to answer that too. So that's where we'll pick up next time, but I wanted you to see this and maybe think about the question, where's it positive, where's it negative, and where's it 0, okay?
So no homework tonight, right?